Hello, programming languages students. Welcome to another Prolog video. I'm making this video by request from a couple students that have asked for a couple pieces of information, and also just to provide a little extra guidance about how recursion works in Prolog. So the example you see in front of me right here, this is actually problem 4 from your collaborative assignment. And I brought this one up because I think it's very helpful for teaching a couple different things that may be causing students confusion. So the first thing is an error that shows up. Um, let me go ahead and run it. Um, an error that says arguments are not sufficiently instantiated. So what is this error? How is it caused? I've had a lot of students talk to me about seeing a lot of this error, um, or something very similar to it. And so the trick to this, and this is important, as you go through, you will see that I give you pluses and minuses when I'm defining predicates. So for example, if I draw something out for you and tell you to make a mystery predicate, you'll see something that looks like this. So when you create this mystery predicate, you'll be, with a plus sign in front of here, you'll be expected to provide this number, like I did here, an actual number, a value, a 1, um, and you'll be expected to print out or return the value with a minus in front of it, or any values with a minus in front of them. So you'd put a variable in here, and when you run the predicate, then you'll get the variable printed out. So why is this important? Why is this helpful? And in particular, for avoiding this arguments are not sufficiently instantiated thing. Well, as you go through, you're going to be doing some math. You're going to be changing values between iterations. And so it's important to note that when you write these is statements, this is how you can actually do math, right? Is lets you do math, equals just a unifies a thing. So we want to do math. And so this math we're doing is setting the variable n1 equal to the value of n minus 1. Well, I can have this line up at the front of my code. Notice I've now switched to the front. If I run this, I no longer get, now I get a different error, but no, I no longer get the arguments are not sufficiently instantiated error. So um, the reason I don't get this error anymore is that I have sufficiently instantiated my arguments. In other words, as I go through, I'm going to do this math, I need to know what the value of n is, so I can subtract 1 from it and save it in this variable n1. The reason this works is because I am provided with the n value, this first number, this 1. So when I put in my query, I get 1 as the starting value here. That means I can do the math to figure out that n1 is 0. Now, as I go forward, if I put this after the mystery predicate, or actually more importantly, I'll show you a different error, um, we'll run into an error. We'll have a problem. So given a value, you can do math with that value before you recursively call. That's important. Now, the x value here, this is not given. This is expected output. I cannot do math with x, whether on the right or left side, before my recursive call. See, now if I run this, I get arguments are not sufficiently instantiated. That's because I'm trying to do math with a value that I have not provided before there is a chance for me to calculate that value. See, the way it works is we start with mystery 1. We're going to recursively call to go to mystery 0. We're going to find this base case, take the 3 from this, and then work our way back up recursively until we get to the original statement. So when I'm trying to work up recursively, that's when I actually get this n1x value. Imagine in this case we have mystery 1. That means we're going to do one recursive loop. I would need to go into mystery 1 time with an input value of 0 to get an output value of 3 as n1x, which I can then do math to give me my output variable. So the order matters here. I need to call mystery first so that as I recursively go through mysteries, I can eventually calculate this n1x from my base case. And then as I work my way back up, I take the n1x from my base case, I add 3 to it, and pass that value along to the previous call, to the higher up call in my recursive hierarchy here. So the bottom line here is the really shortcut. If you're going to pay attention to anything, pay attention to this. If you are provided a value, you can do math with it before your recursive call. If you are not provided a value, if you're supposed to output a value, it needs to be, the math for that value needs to be done after the recursive call. That will help you avoid this arguments are not sufficiently instantiated error. Okay, now the second thing I want to talk about is do one more example while I've got it up here about how recursion works. So obviously, I ask you what the printout is from this query. Well, you could plug it in and find out. The whole point of this being in your assignment, your collaborative assignment, is not to see whether you can type this into Prolog, although hopefully you can type it into Swish. But it's to help you have an example that works in front of you so that you can see how maybe a math series works before you work on problem 5 to actually write your own math series. So the way this works, this is basically, this mystery predicate here is basically a math series that's doing one particular operation. So let's see if we can figure out what that operation is. Now, n, the value we pass in, this first value is which number in our math series do we want. So in this case, in the example I gave you, we're looking for the fourth item in that math series. Well, let's change it to the first item so we can do a really simple example here. We could even do the 0th item. So the 0th element in this math series, if I run it, is 3. And right now I'm just hitting stop. I'll show you the difference that stop has, and that'll be one other final point to this exercise at the end. So mystery 0, comma x gives us 3. That makes sense, right? So let's try mystery 1, comma x. Well, if I try mystery 1, comma x, I'm going to first try the top predicate. Well, there's no match here because 1 and 0 do not unify. So I try the second predicate. So n is 1. So therefore, and note this is on the left side of my recursive call, but that's fine because n is 1. This is given. Therefore, I can calculate what n1 is. Therefore, n1 is 0. Right? Now I can call mystery. Therefore, I can call mystery with 0 and n1x, a variable that I do not know its value yet, which I will need later for when I calculate x and n1x. So first we need to resolve this mystery call. So we get mystery of, well, 0, comma 3 is the first thing I check, and hey, that matches. 0 unifies with 0, this is great. So I can pass this 3 up and say, all right, this is a working solution. A solution to this is if this mystery is 0, 3. That means that n1x is 3. Therefore, x is n1x, which is 3 plus 3. So x is 6. That means that when I finally go back up to my original mystery predicate with n and x is 6, and so when I run this, I will get 6. Now, why do I have to stop this? Let's run this one more time. Well, there's no limit to stop calling mystery. I find one solution that works with 0. So I tried calling mystery with 0 and that worked, but this call can keep going. Or actually, no, my recursive calls can keep going. Once I have checked mystery, sorry, this is the correct answer to this. Once I have checked mystery with 0 and found this predicate that worked, I still have another predicate to check. So this worked, but on this iteration, there's still another predicate to check. Mystery n comma x, where n is 0, and I need to find x. So that means I'm going to try mystery again with -1. Well, there's no mystery that matches with -1, but I can try mystery again with -2, and -3, and -4, and -5, and -6, and -7. And so that's why we get the stack limit exceeded after we find one correct answer. So the quick solution to this is if you look at my backtracking and cutting video, is if we add a cut to the base case. This means once we have found one base case, we stop backtracking. So now I find x equals 6, and there's no next, no stop, so this is a good, proper way to write this method. Now, let's make sure we get it before we move on, before we finish the video. Mystery 2, comma x. Let's make sure we understand and know what this whole predicate is doing. We take n, which is 2 now, and we call mystery with n1, which is 2 minus 1. So we're basically adding one level of recursion here. N is 2, therefore n1 is 1, therefore mystery is called on 1 n1x. And then we'll have some other stuff to do. So this recursive call basically calls this, which we've already walked through, which goes down one more stage, and that sends us to the base case. And so we find mystery 0, comma 3, and now we have a backtracking cut so we don't keep going. We find mystery 0, comma 3, which means this n1x is 3, which means this x is 6, which recursively calls up here to say that n1x is 6, which means that on this iteration, x is 9, right? 6 plus 3 is 9, which then passes out as our answer, so we get 9. So what is this series? Well, element 1 of the series is 6, element 2 of the series is 9, element 3 of the series would be 12, element 4 would be 15, and so on. And so what is the series? Well, every element in the series is 3 more than the last, and element 1 in the series is 6, or element 0 in the series is 3, depending on how you write it. So hopefully this helps you with a little bit of math series, a little bit of how backtracking and cutting helps, and also a little bit of how to avoid these arguments are not sufficiently instantiated error. The key is if you're provided the value, you can use it before you recursively call. If you're not provided the value, if it's a value you're calculating, it needs to be after your recursive call so that as you work your way up the tree, you have actual numbers to do math with rather than variables. So hopefully that helps. Please let me know if you have any more questions.